Hello everyone. Welcome to my YouTube channel on engineering mathematics. In this video, we are going to discuss rectification of the curves given by the equation x is equal to f of y. In the first lecture of this series, we have already seen length of the curve given by the equation x is equal to f of y is given by s is equal to integration of under root of 1 plus dx by dy square dx over the limit y1 to y2. Where y1 and y2 are respectively y coordinates of the endpoints of the curve x is equal to f of y. Now let us see examples that uses this technique. In this example, we are asked to show the length of the parabola given by y square is equal to 4ax from the vertex to the end of the latus rectum is a into root 2 plus log of 1 plus root 2. So in short, we have to find length of the parabola at certain points. Let us talk about this latus rectum. We know latus rectum of the parabola is the line segment passing through its focus and is perpendicular to its axis. Below is the latus rectum for the equation y square is equal to 4ax. This is your parabola y square is equal to 4ax, and this blue line represents its latus rectum. Note that this latus rectum is perpendicular to the axis of the parabola. This is the focus of this parabola whose coordinates are a, 0. This much distance is 2a. Similarly, this distance is also 2a. Therefore, coordinates of the points a and b are respectively a, 2a and a, minus 2a. We have to find the length of this parabola y square is equal to 4ax from its vertex, that is origin, to a. And equation of the parabola is y square is equal to 4ax. Then differentiating both the sides with respect to y, we will get dx by dy is equal to 2y by 4a, that is y by 2a. And since this equation of the curve is of the type x is equal to f of y, its length can be given by the formula s is equal to integration of under root 1 plus dx by dy the whole square dy over the limit y1 to y2. Here y1 is y coordinate of this point O, which is obviously 0, and y2 is y coordinate of this point A, which is 2a. Now let us substitute value of dx by dy into this RHS part. We have seen dx by dy is y by 2a. Let us substitute it over here and simplify. So after substitution, we see RHS is integral of under root of 1 plus y by 2a square dy. Then this can be written as y square upon 4a square. Then cross multiplying this and taking out 1 by 4a square, we have 1 by 2a outside the integral, and inside the integral we will have under root of 4a square plus y square dy, whose value can be given by y by 2 into under root of y square plus 4a square plus 4a square by 2 into log of y plus under root of y square plus 4a square over the limit 0 to 2a. Now let us substitute these limits in y. So after substitution of this 2a in y, we have 2a by 2, that is just a, into under root of 2a square, that is 4a square plus 4a square plus 4a square by 2 into log of 2a plus under root 4a square plus 4a square minus, after substituting lower limit in this term, we get 0 plus 4a square by 2 into log of 0 plus under root of 0 plus 4a square, that is under root of 4a square, that is nothing but 2a. Now let's simplify this. This 2a by 2 is just a. Under root of 8a square can be written as 2 root 2 into a plus 4a square by 2 is 2a square. Similarly, this 4a square by 2 is 2a square, which is common term, we will take it out. Now inside the bracket we will have log of 2a plus under root of 8a square is 2 root 2a minus log 2a. Now we see this a square and a square is common term. Let us take it out. So we have a square upon 2a into 2 root 2 plus 2 into log of 2a plus 2 root 2a upon 2a. Here we are using property of log, which says log a minus log b is log a by b. Now finally, we take out this 2 and 2, which is a common term in the numerator, and that 2 will get cancelled with this 2. Same thing happens with this a. So this a and a will come out and it will get cancelled with this denominator a. So we will be left with log of 1 plus root 2. Now this 2 and this 2 will come out and it will get cancelled with this 2, and this a square and this a will get cancelled, so we will have only a outside the bracket. So length of this curve is a into root 2 plus log of 1 plus root 2, which is the required answer. I hope you understood this solution. Now let's go ahead for next example. Here we are asked to find length of the curve given by x is equal to y raised to 4 by 4 plus 1 upon 8y square from point y is equal to 1 to y is equal to 2. Let us first note the equation of the curve. Here it is of the type x is equal to f of y. Now we can find out dx by dy from this by differentiating it throughout by y. So dx by dy is 4y cube upon 4, so that 4 gets cancelled, we left with y cube, plus 1 by 8 is constant. Derivative of 1 by y square is minus 1 by y cube into 2. So which simplifies to minus 1 by 4y cube. Now we assume length of the curve is s. So it is given by integral of under root 1 plus dx by dy square dy over the limit y1 to y2. Here y1 and y2 are already given in the question. They are 1 and 2 respectively. Now let us substitute value of dx by dy, which is y cube minus 1 by 4y cube, like this. Now this is like a minus b whole square, which can be expanded as a square minus 2ab plus b square. Now this 1 and minus half is nothing but just half. So we have y raised to 6 plus half plus 1 by 16 y raised to 6 dy. But this is nothing but y cube plus 1 by 4y cube whole square. You can pause the video and check the calculation. Now this square root and this square will get cancelled. So we have s is equal to integral of y cube plus 1 by 4y cube dy over the limit 1 to 2. Now let's calculate this integration. Integration of y cube is y raised to 4 upon 4. This 1 by 4 is constant, we will keep it as it is. Integration of y raised to minus 3 is y raised to minus 2 upon minus 2, which simplifies to minus 1 by 8y square over the limit 1 to 2. Now let us substitute these limits in y. After substituting this upper limit 2 in y, we have 2 raised to 4 upon 4. This 4 can be written as 2 square. So this 2 raised to 4 upon 2 square gives 2 square minus 1 upon 8 into 2 square. Now let us substitute lower limit. So after substituting lower limit 1 in y, we have 1 by 4 minus into minus plus into 1 upon 8 into 1, that is 1 by 8. When we simplify this, we found the answer is 123 upon 32. This is length of the given curve. Now let's go ahead for next example. Here we are asked to show that the length of the parabola given by y square is equal to 4ax cut off by the line 3y is equal to 8x is a into log 2 plus 15 by 16. Now in this question, the endpoints of the parabola are not mentioned, between whose length we have to find out. So to find those points and their coordinates, we have to find the intersection of these two curves, that is parabola and the line. This is the figure of parabola y square is equal to 4ax, and this blue line represents line 3y is equal to 8x. Now let me show you this point of intersection is 9a by 16 comma 3a by 2. For that we will substitute this equation of a line into this parabola. So from here we get y is equal to 8x by 3, by substituting which into this equation we get 8x by 3 square is equal to 4ax. This 8x by 3 square is nothing but 64x square by 9, which simplifies to x is equal to 9a by 16. Look at here, this square and x will get cancelled. Similarly, 4 16s are 64, and when this 9 and 16 taken on the other side, we get x is equal to 9a by 16. Now we substitute this value of x into equation of line. So we get y is equal to 3a by 2. Therefore, coordinate of this point of intersection are 9a by 16 comma 3a by 2. We are asked to find length of this parabola cut off by this line, and this line cuts this parabola at origin as well as at this point. So we have to find length of this parabola from origin to A, and from origin to A y varies from 0 to 3a by 2. So these are limits of our integral. Now let's find out value of dx by dy from equation of the parabola, which is y square is equal to 4ax. Now differentiating this with respect to y, we get dx by dy is equal to y by 2a. Now we substitute this value of dx by dy and these points into the formula for length of the curve given by integration of under root 1 plus dx by dy square dy over the limit y1 to y2. Here clearly y1 is 0 and y2 is 3a by 2. Now let's substitute value of dx by dy into this, that is y by 2a over here. We get length of the curve s is integral of under root 1 plus y by 2a square dy over the limit 0 to 3a by 2. Let's simplify this. Then this will become y square upon 4a square. Then we multiply that 4a square with this 1, and we take out that 4a square outside the integral. So we have 1 by 2a outside the integral, and inside we will have integral of under root of 2a square plus y square. Now this integral looks like integral of under root of alpha square plus y square dy, whose value can be given by y by 2 into under root of y square plus alpha square plus alpha square by 2 into log of y plus under root y square plus alpha square. Here alpha square is 2a whole square, so alpha is 2a. Here limits are 0 to 3a by 2. Now we substitute these limits in y. 3a by 2 that is 3a by 4 into under root of 3a by 2 square, that is 9a square by 4 plus 4a square plus 4a square by 2 into log of y, that is 3a by 2 plus under root of y square, that is 9a square by 4 plus 4a square, minus, after substituting lower limit 0 in y, we get 0 into this term, that is 0, minus 4a square by 2 into log of 0 plus under root 0 plus 4a square, that is under root of 4a square, that is just 2a. Now let's simplify this. After cross multiplying this, we will have 16a square plus 9a square, that becomes 25a square by 4. So we have under root 25a square by 4 here as well as here. This 4a square by 2 becomes just 2a square. Similarly, here also we will have 2a square into log 2a. Now this 2a square and this 2a square is a common term. We can take it out, as well as this 25a square by 4 is in the under root sign. We can write it by removing this under root sign as 5a by 2, like this. And when we took out this 2a square common, we have log of 3a by 2 plus 5a by 2 minus log 2a. Now this is like log a minus log b, which can be written as log a by b. But this is 3a by 2 plus 5a by 2, which is nothing but 8a by 2, which is just 4a. So log 4a minus log 2a will be log 4a by 2a, that is log 2. So we have log 2 after simplifying this part. When we multiply these terms, we have 15a square by 8. Now let's take out this common a square and we multiply this 1 by 2 inside the bracket. So we have a square by a outside and 15 by 16 plus this 2 gets cancelled, log 2 inside the bracket. Now this square and a will get cancelled. So we get length as a into 15 by 16 plus log 2, which is the required length of the curve. I hope you understood every step of this solution. In my next session, we will see examples of finding length of the curve given by its parametric equations, that is x is equal to f1t and y is equal to f2t. Till then, thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.